I'd like to redo problem number 6 from section 4.4, the notes I gave you in class. In this case, I've given you a cost function. It's easier to see here in the large print, but the cost function is 4q cubed minus 12q squared minus 36q. In order to find the average cost, remember what I do. I take the total cost, or my cost function, and I divide by the number of items, q. So in this case, my total cost function was what I just read. I put that over q, and in this case, quite frankly, I have a q in every term. What I literally can do is take a q out of every single term then. Taking 1 in the denominator would just leave me with a 1. And effectively the denominator is gone and I have only the numerator left. In the numerator, I merely take out 1q from each one of my terms. So I had 3 here, I now only have 2. I had 1 here, I now only have 1. I had 1q here, and of course I have no q's left since it canceled. Let's look at B. In this case, I want to find the point at which the average cost function is lowest. I'm looking for a critical point. I want to find the maximum or minimum, and you'll recall that wherever the maximum or the minimum occurs, the derivative at that point equals 0. So let's go ahead and take the derivative of my average cost function, which would give me 8q minus 12. I set that equal to 0 in order to determine where that maximum or minimum occurs. In this case, it's the minimum that we'll be finding. I add 12 to both sides of my equation. I get 8q equals 12. And finally, I divide by 8 and I get 1.5. So in this case, you'll recall that Q was the thousands of items produced. So producing 1,500 items will actually result in the average cost being the lowest. Now, let's go ahead and find the point at which the marginal cost is the lowest. First of all, I'm going to go ahead and find the marginal cost by taking the derivative of my original equation. Taking the derivative of my original equation left me with 12q squared minus 24q minus 36. Now you'll recall again, what I want to do in this case is find where this is at the minimum. I'm looking for the minimum of this function, so again I have to take the derivative of this function. Taking the derivative of this function yields 24q minus 24. And again, at the minimum, I know this derivative will equal 0. Adding 24 to both sides of my equation yields me 24q equals 24, so q must equal 1. So purchasing 1,000 items would result in the lowest marginal cost. Or in other words, the cost of producing the 1,000th item is cheaper than it was to produce the 999th or the 2001st item.